Good morning, everyone. Today we are focusing more about motion graphs. Already we studied about different types of graphs such as displacement time graph, velocity time graph, acceleration time graph, and about the bouncing ball. And today the main objective of today's lesson is students should be able to develop question answering skill from the topic graphical representation of motion. So today we will give different questions and we can see how we have to write the answers for each questions. So question number 1. A student investigated the motion of a small rectangular panel. The panel was held above the floor next to a measuring tape. The panel was released and using a video camera on a smartphone, its motion as it fell to the floor was recorded. Using the position of the panel at regular time intervals, the velocity of the panel was obtained. So a diagram is given, a smartphone over here and the table, the measuring tape, it's vertical measuring tape and a rectangular panel. The rectangular panel was released from this much height, and in this question they given a graph, a velocity time graph. The velocity time graph shows the motion of the panel until it reaches the floor. So a velocity time graph is given. Velocity is given in meter per second, time is given in second. The x-axis is labeled and y-axis also labeled, and the graph is given. The question: show that the panel was dropped from a height of approximately 5 meter. It's a 3-mark question. We should have to find height. How we can answer this question? So it's a velocity time graph. Height means its displacement. So from velocity time graph, how we can find height or how we can find displacement? Yes, it's the area under the graph. But here there is a small issue. The area, the graph is not a regular shape. It's a curved graph. So what to do in this situation? So in this situation, anyhow we have to find the area under the graph. But in this particular situation, what we have to do? We have to count the boxes. How we can count? Let's see. So look at this. So what you have to do is you have to count. You can see I just marked here a rectangular box. So you have to count how many boxes are here, like under this graph, under this velocity time graph, how many boxes are there. So you count each boxes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Like that you count all the boxes. But in here that box is not full. So you just take this and here one. So approximately you count the boxes. And remember, in each box there are 25 small boxes are there. Okay, like this 25 small boxes will be there. So you just count approximately how many this much size boxes are there. So count all the boxes, and after that find area of one of the box and multiply it by number of boxes, so you will get the displacement. So let's see once again. Here it's a 3-mark question. So what are the points you have to include in order to get the 3 marks? So let's see. So in this question, if you use area under the graph, so you will get 1 mark. And how you can what method you can use to find area under the graph? Use of counting squares method to find the area under the curve, or approximate the area to at least one triangle and one rectangle. You just make it one triangle and one rectangle. That method also you can use, but here the counting squares method is more relevant. Then if you do the calculation, you will get height is equal to 5.2 to 5.5 meter. So what they did, example of calculation is given over there. Area under the graph is equal to, there are 27 square centimeter squares are there, into area of one square. So area of one square, that is 0.2 second into 1 meter per second. So when we do this calculation, we will get height is equal to 5.4 meter. Okay, then let's go to second question. See, a train moves between two stations. A simplified velocity time graph for the motion of the train is shown. A velocity time graph is given. Velocity axis are marked and time axis also marked. Here, draw a corresponding acceleration time graph for the motion of the train. Show all walking in the space below. It's a 6-mark question. What you have to do, you have to draw an acceleration time graph corresponding to this velocity time graph. So how we can do that? And in the same question, they given the acceleration time graph. So acceleration time graph, that graph is given, so you have to draw in this paper. In this graph paper you have to draw. So let's see once again. So how we can find the answer? So first of all, you remember we have to draw an acceleration time graph. So here we can consider different time intervals. At first, means at this point what is happening? Here velocity increasing constantly, and here velocity is constant, and this point velocity decreasing constantly. So we can say in this case acceleration, the train is accelerating. So from here the train is moving with the constant velocity or uniform motion, and in this case the train is decelerating uniformly. So acceleration is there positive. Here acceleration is the gradient, so acceleration is positive and constant. Here the acceleration is 0, and here the acceleration is negative and constant. So now we got an idea how the graph looks like, how an acceleration time graph looks like. But we need to know the value of acceleration. Here the value is 0, understood. But here what is the value of acceleration, and here what is the value of deceleration. So in order to get acceleration, what you have to do in this case? Here we know gradient of velocity time graph is acceleration. So here acceleration is equal to gradient. So we have to find the gradient. And here gradient is equal to 0. So acceleration is 0. Here gradient is negative. Gradient is negative means we have to find the gradient by drawing a big triangle and find the gradient. So after that what you have to do, we have to draw the graph. So uh, it's a 6-mark question, so let's see what are the marking points. What are the points you should have to include in your answer? Let's see. So we have to draw the graph, right? So acceleration axis scaled using at least half of grid. Okay. Then constant acceleration drawn onto the graph between 0 second to 40 second. That's what first we found the acceleration, and zero acceleration between 40 second to 300 second. Okay, and vertical solid dashed lines at 40 second and 300 second. Then final negative constant acceleration drawn onto a graph between 300 second and 360 second. So in order to find acceleration or deceleration, you can use A is equal to V minus U over T, or you can use the gradient method. Then acceleration and deceleration you have to find. So first part, acceleration is 0.68 meter per second square, and the second part it is 0, and the third part it is minus 0.45 meter per second square. So you have to show this calculation. So when you draw the graph will be like this. First, constant acceleration. Here the vertical line should be there. This represent the object is moving into the next level, like zero acceleration. Here zero acceleration, 300 to 360 second. It is again constant but negative. Okay, so this is the graph. So you have to draw the graph. You have to find the acceleration time graph, acceleration and deceleration, and correct plotting. The times interval should be the same. Okay, if you do all, if you uh, mark all this point, means you will get a 6 mark. Okay, then we can move to the next question. Third question: a ball is dropped and reaches the ground after 0.42 seconds. The ball bounces and is caught at the same height from which it was dropped. Draw on the graph paper below the velocity time graph for the motion of the ball. You may assume that the time the collision with the ground takes and all frictional forces are negligible. Show you're working in the space provided. So here in this question, the time is given 0.42 second. We have to draw a velocity time graph. So first we have to find the velocity. So we are going to draw a velocity time graph. Time is given 0.42 second. Then here we have to draw a velocity time graph. So we need a velocity. We need maximum velocity. Here the ball is dropping from certain height and it reaches the ground. We have initial velocity, that is 0 meter per second or 0. Final velocity, when you hit the ground, final velocity we have to find. So in order to find final velocity, we can use the equation V is equal to U plus AT. In this equation, U is equal to 0, A is 9.81 and T is 0.42. When we do calculation, we will get the maximum velocity or highest velocity is 4.1 meter per second. Means when we drop the object, initial speed is 0 and it reaches a speed of 4.1 meter per second in 0.42 second. It hit the ground and it bounces back. It bounces back with the same speed 4.1 meter per second, and it when it moves up it decelerates, and at maximum height the velocity again 0. So the total time, downward motion and upward motion. Downward motion, the time is 0.42 second, and for upward motion the time is same 0.42 second. In the question itself it says all the external factors are negligible. So the upward time and downward time will be equal, so the total time will be 0.84 second. Next, we got the maximum velocity and we got the total time. So next step, we have to plot the velocity axis, and we have to scale the time axis. So here Maximum velocity is 4.1 meter per second, so we can plot velocity like starting from 0 in positive side plus 1, 2, 3, 4, 5, and down also we can plot minus 1, minus 2, minus 3, minus 4, minus 5. Then the total time, upward motion 0.42, downward motion also 0.42, total is 0.84. So we can plot like 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 until 1.0. We can plot like that. After that, we can draw the graph. How the graph will be looks like. Let's see. Here, the initial velocity is equal to 0 and the ball is moving down. We can consider the motion is negative. So, the velocity increases but in opposite direction and reach maximum speed 0.42 at 0.42 second. The maximum speed is 4.1 meter per second. Then it bounces back. The direction of velocity changes. This vertical line represents the direction of velocity changes. We consider with the same velocity the ball bounces back. So 0.42 second to 0.84 second, the ball is moving with constant acceleration from 4.1 meter per second to 0 meter per second. So the graph will be looks like this. So you have to draw this graph. The total mark for this question is 5. So we can see what are the marking point. What are the things you have to include in your answer. Let's see. First point, use of V is equal to U plus AT to find the maximum velocity or velocity at which it hit the ground. Axis scaled correctly. Velocity axis and time axis you should have to scale very correctly. Then first a line from 0, to 0.422 minus 4.1. Then vertical line linking positive and negative velocity. Means that vertical line represent the direction of velocity changes. Then after that a line from 0.422 plus 4.1 to 0.84 to 0. 0.84. So if you include all these you will get 5. Okay. Then let's see the next question. Fourth question. The graph shows how velocity varies with the time for an object. A velocity time graph is given and the question is the total distance traveled by the object in 4 seconds is. Actually it's a simple question. So a velocity time graph is given. From velocity time graph how we will find a distance? Easy. We can find area under the graph. So here how we can find area under the graph? You can use a trapezium method because it's a shape like a trapezium, or you can consider 0 to 2 second it's a triangle and 2 to 4 second it looks like a rectangle. So you can use a triangle and a rectangle separate. So first triangle. The area of triangle is half into base into height. So here half into 2 into 20. Half into 2 into 20 is equal to 20. And next for the rectangle. Rectangle, the height is rectangle, the area is base into height. Here height is 20 and base is 2 to 4 second. 2 to 4 second means it is 2 second. So 2 into 20. 2 into 20 is 40. 40 plus The triangle area we already calculated, that is 20. So 20 plus 40, 60. So the answer will be C, 60 meter. So in the exam paper, you have to tick a cross on the box given. Okay, so it's an MCQ. It's a simple question. Okay, so we can move to the next question. The photograph shows a toy car driven by air from a deflating balloon. When the air in the inflated balloon is released, the car starts to move forward. So here, air escaping from the balloon. A balloon is there. When the air escaping from the balloon, the car is moving forward. And corresponding distance time graph is given. See, the following distance time graph is obtained for the car. Distance is given in centimeter, time is given in second. Show that the maximum speed reached is between 100 and 150 centimeter per second. Here the speed unit is given centimeter per second, and here in the graph distance also given in centimeter. So no need to convert. Here we have to find the maximum speed. How we can find speed from distance time graph? Yeah, it's a gradient of the graph. So maximum speed we have to find. Maximum speed means maximum gradient. So at which point the gradient will be maximum, that we have to check. So we can closely observe this graph. At the beginning, the gradient is 0, then gradient is increasing. Here the gradient is increasing, and at this point gradient is maximum, and the gradient is decreasing, and at last the gradient is equal to 0 at this point. So here we have to find the maximum speed. Maximum speed means maximum gradient. So we can find the gradient at this position. At this point we can find the gradient. But it's a curved graph. For curved graph, how we can find the gradient? We have to draw a tangent at this maximum position. Let's see. So this is how you have to draw a gradient. A straight line, you can draw a straight line at that point and find the 2 point. You can find the 2 points from it, like y2, y1 and x1, x2. From here you can take y2, and this y1 you can take as 0, and x1 you can take this value you can take as x1, and this value you can take as x2. Then you can use the equation y2 minus y1 divided by x2 minus x1 to find the gradient. That gradient will be the speed. Here this gradient is maximum, this is the maximum gradient, so that will be the maximum speed. So how we can what are the points we have to include? It's a 3 mark question, so what are the points you should have to include in your answer? Let's see. You should have to draw a tangent on graph, or you have to state use of gradient, or show use of a grade. You have to show the working, or you have to state you are using a gradient, or you draw a tangent on the graph, and after that the value of gradient you can find, and correct answer you will get around 120 centimeter per second. Calculation is given. V is 120 centimeter, like minus 0 centimeter, 1.9 centimeter minus 0.9 second, like that. 120 centimeter minus 0 divided by 1.9 second minus 0. This is how they found the gradient. Then we will get the answer 120 centimeter per second. So you can draw, when you draw a gradient you will get your own value, means your the height of the gradient, and it will be different from this. So it's an example calculation, so you have to find your own value. Okay, make sure that always when you find the gradient, take a big triangle, take a big triangle on the straight line, then your answer will, we will get an accurate value. So these are the some questions I just explained. Okay, then next I am giving some two assignment, follow-up activity assignment 5 and assignment 6. I included many questions in these assignments. Uh, so the deadline, the due date also, I will inform you through Viber. So you please complete it on time. Okay. Thank you. Thank you very much for watching my video. See you. Bye.